Welcome, everyone, and thank you for joining us today for this virtual seminar. We are pleased to have with us Dr. Regan Bailey, Associate Director at Texas A&M AgriLife Institute for Advancing Health Through Agriculture. Dr. Bailey is an internationally recognized nutrition scientist and registered dietitian who joined Texas A&M from Purdue University. She is an elected member of the National Academy of Medicine for her work on measuring nutritional status to optimize health. She's currently serving on the National Academies of Sciences, Engineering, and Medicine's Committee for Dietary Reference Intakes for Energy. Dr. Bailey has multiple publications as well as awards and is really well known in the field of precision nutrition. Dr. Bailey's research has focused on how dietary intakes relate to health outcomes. She has created models combining nutrients from foods and dietary supplements and used these models to identify differences in nutritional risk by gender, race, ethnicity, life stage, and income, suggesting the need for population-specific interventions and public health policy. At Texas A&M will build on our expertise, leveraging the study of precision nutrition, which seeks to understand nutrition based on individual differences in responding to diets and their impact on health. Welcome, Dr. Bailey. We look forward to hearing about your work. We will have a Q&A session, as always, at the end. So for our audience, we please request you to post your questions in the Q&A box. Dr. Bailey, welcome and take it away.
We have the right slide view here. Are we in the right slide, or do I need to switch screens?
You need to switch, please. Thank you.
Okay, there we go. So thank you so much, Dr. Doss, for that nice introduction and for the invitation to be with you all today. So I'm going to briefly share with you some recent work out of my research lab, the development and validation of the total nutrient index. And there are many, many diet quality indices that exist. And so I don't have all of them on this slide, but here are some examples that you're most likely familiar with. The DASH diet index, the Mediterranean diet index, the healthy eating index. So these largely focus on food-based recommendations, and you'll see the scoring for the HEI down here. So it focuses on things like fruits, vegetables, dairy. There are some nutrients included like sodium and types of fat. And using that HEI, this is a score from 0 to 100 on how well American diets conform to the dietary guidelines. So I always tell my students the HEI is like an exam. You want a high score or 100, and this is where we are. And we see that children are around 60. It decreases through early childhood and then increases throughout older adulthood. And because these are largely based on food and beverage intakes, we sought to develop this nutrient index because we know that many, many Americans are using dietary supplements, primarily in the form of multivitamin, multi-mineral types of products. And so we know that half of adults and about a third of children are using dietary supplements. And so the existing indices don't really take into account nutrient exposures from dietary supplements. What's also interesting is that you'll see that these are the percent of Americans using a dietary supplement, primarily those nutrient containing ones, that it's higher prevalence in young childhood, decreases at around the same time that diet quality tends to decrease, and then use increases as people continue on their life course. So older adults use more dietary supplements than any other life stage group. And so I always get the question, why? Why do we care? Well, dietary supplements, or DS as I have in most of my slides, can provide more than 100% of the daily value for some nutrients. And so on this slide, I'm just highlighting 9 that one product in general provides more than 100% of the recommendations for nutrients. So if we're not taking into account exposures from nutrients, we're really missing a lot of nutrient exposures. And so in this slide, in yellow, is showing the contribution from supplements for specific nutrients. So you'll see that 84% of the vitamin D in females older than 70 are coming from dietary supplements. And this varies from nutrient to nutrient. So for things like calcium, it's relatively low in younger adults. Same thing for magnesium, but for some nutrients like vitamin D and vitamin C, supplements provide more than half of dietary exposures for a given day. And so if we don't incorporate dietary supplements into exposure assessment, we are not really getting the totality of exposures. And so up until the point that we developed this index, there wasn't really a metric designed to assess total nutrient exposures inclusive of dietary supplements. And that's important because we need both accurate and reliable methods of these exposures for public health monitoring. So who is getting too little, who is getting too much, that's usually what we're worried about, or we want to relate dietary exposures to some health outcome. So that's really the background of why we sought to develop the total nutrient index. As I mentioned, without inclusion of supplements, exposure classification is incomplete. And by developing the total nutrient index, we are not in any way trying to take away from those foods and beverage-based index. What we want to do is have some complementary information that can be used with those indexes that I provided on the first slide, like the HEI. So all of this work is based on NHANES, or the National Nutrition Health and Monitoring Study, which is representative of the US population. And I have some of the background on NHANES, but I'm sure most of you are familiar with the NHANES methodology, but there's a reference at the bottom if you need more information on the NHANES methods. So in addition to the total nutrient index, which includes dietary supplements, we first developed what's called the food nutrient index, or FNI, and then the TNI expands that to include dietary supplements. At the time that we developed this, we were utilizing the 2015 to 2020 dietary guidelines for Americans, and we sought to capture those nutrients that were listed as nutrients of public health concern across the population, or shortfall nutrients. So both the TNI and the FNI have those 8 nutrients at the time. And so, these change with every iteration of the dietary guidelines, but in general, a lot of these are continually low in the US population. So really, the concept is the same. We take usual nutrient intakes, so adjusted using the National Cancer Institute method to take care of day-to-day variation. So at the population level, how does the mean usual intake compare to the recommended dietary allowance, if we have one, or if we do not have one, how does it compare to the adequate intake? So it's basically very much like the HEI in that we have several components, and each of those sum to a total score of 100. And so this is just reminding you all of what the RDA is. This is the amount of a nutrient that is recommended to meet the needs for almost all of the population. So these are set by sex, age, and life stage groups. So we're really focusing at the most around the RDA when we have one, and the adequate intake when we don't have an RDA that's established. So in terms of developing the TNI, as I mentioned, we use the NHANES as our sample to develop and validate this. We excluded pregnant and lactating women. We sought first to focus this on adults. We're now extending that into other age groups. And so for this study, we excluded people that did not have dietary intake data. So that was about 10,000 people representing the US adult population in the years 2011 to 2014. This is just some background on the statistical analysis. So as I mentioned, we have measurement error with self-reported diet. So there's a lot of within-person variation, so day-to-day variation, which we can mitigate with statistical models like the NCI method. There are always issues of energy underreporting or systematic error that we do not have the ability to deal with. And so, as I mentioned, the TNI is very much like the HEI in that the score ranges from 0 to 100. So we can see that in general, of all US adults, based on those 8 nutrients that we developed the TNI on, the score was 75. And as we would expect, scores were much higher among supplement users. Supplements contribute a lot of nutrients to those who use them. And so you see it overall, and then here are the scores stratified by supplement use. So this is a radar plot. I sometimes call it a spider plot. What you want to see is things closer to the outside. So scores that are higher would be around the outside of the perimeter. And so you can see very clear differences in the component scores, for example, vitamin D. So a component score for a non-supplement user is around 30, whereas in a supplement user, it's 80. Ideally, these would all be 100. So again, we are not close to the targets, in this case, the dietary reference intakes, but for some nutrients, you can see a very, very big division for certain nutrients. So things like potassium, there's not a lot of potassium in dietary supplements. So there's very little variation by supplement users for certain nutrients. And that's true for potassium and for choline. But you can see across the rest of the nutrients, we really see substantial differences in these component scores. And so overall, to summarize that part, we know that supplement users have higher score on the total nutrient index, and that is why we intended to do this, to provide something that represents usual nutrient exposures from all sources. And so I presented some of that work for users and non-users and how that differs by particular nutrients. So that was the development of the index. Let's look now at some of the validation tools that we used for the index. So our objective here was to really assess the degree of construct and criterion validity specifically. And again, looking at those underconsumed micronutrients among non-pregnant, non-lactating US adults. And so we have 4 specific questions. I'm going to walk through each of these. But first, was the TNI able to demonstrate validity in regard to exemplary menus? So exemplary menus are designed to maximize nutrient intake across different populations. Could the TNI differentiate between groups with known differences in their nutrient intakes? What is the relationship with this new tool relative to other more established tools like the HEI 25 or HEI 2015? And then importantly, because of all the measurement error with self-reported diet, how do our component scores compare with biomarkers of nutrient status? So first, we evaluated 4 different exemplary menus: the USDA food patterns, the DASH diet, the Harvard healthy eating pattern, and the AHA no fad diet. So we used a 2,000 calorie benchmark across all of these diets. And while they're all very similar, there's a lot of recommendations for fruits and vegetables. They differ on certain constructs. So for example, the Harvard healthy eating pattern limits milk and dairy with an emphasis on reducing added sugar. The DASH diet really focuses on fruits and vegetables as well, but more of an emphasis on reduced sodium intake. Nevertheless, all of these exemplary menus should have high nutrient density in them. And indeed, that is what we saw. And so we compared men and women of different ages based on that 2,000 calorie recommendation. And you'll see that the FNI score, so this is just from foods alone, because these recommended diet patterns are just foods and beverages. And indeed, across all of them, the TNI performed quite well. So a range of about 85 all the way up to 93. And you'll see they differ a little bit. As I mentioned, the Harvard, for example, does not recommend dairy. So there's a lower score there for calcium and vitamin D relative to some of the other eating plans. We know that different groups, population subgroups, have differential dietary quality. And so was the TNI able to differentiate between these known differences? And indeed it was. And so those who are living with food insecurity and those who are smokers had a lower TNI score relative to their other counterparts. So remember the healthy eating index. This is the 0 to 100. I showed you this at the beginning of the slide. Our next step was to take some of the components from the TNI and relate them to some of the components from the healthy eating index. So it stands to reason that if you have a high dairy score on the HEI, you should have a high calcium and vitamin D score on the TNI. And so we started doing some validation techniques to examine if this was in fact true. We looked at fruit and vegetables, for example. Patterns that have high fruit and vegetables should have high vitamin A and vitamin C scores within the TNI. And so this is a busy slide. So this is just looking at the correlations of the healthy eating index overall with the food and nutrient index, so 0.46. We actually think this is a good thing because we think they're representing different constructs. So I don't think that's a bad news kind of thing, but I'm happy to talk about that. When we look at different component scores, so I talked about calcium and vitamin D, you can see the difference between the FNI, which is higher than the TNI. And this is exactly what we're trying to capture. We're trying to capture a different dimension other than diet. So we would expect these to be lower on average. So you can see vitamin C, vitamin A with the vegetables, and the same kind of phenomenon was observed. So this is actually good news. You never want to see correlation coefficients go down, but in this case, we really did because we want to capture that different dimension of the diet than something like the HEI, which is already established and validated, is doing. Here's where the correlations change and improve, and this is exactly what we're trying to capture. So if we look at the relationship between the vitamin A score, the vitamin C score, D, E, with biomarkers. So remember, we talked about the limitations of self-reported diet. So we want to also examine this relative to biomarkers. And you'll see that across all of these nutrients, comparing just foods and beverages with the TNI, inclusive of dietary supplements, increased the correlation coefficient in a significant way across all nutrients. And these are not, this is not the realm of all nutrients. These are the nutritional biomarkers that we have available to us in the in-hand sample. So certainly we're going to want to extend this to other populations and to other biomarkers. But this is just really the first pass of trying to validate this new index. And so we were pleased that the FNI yielded high scores across those exemplary menus, that scores were significantly different for groups that we know from the literature have differential nutrient intakes. It's moderately correlated with the HEI, which again, I think is a success story. We want to capture different dimensions of the diet, and importantly, the TNI component scores were significantly higher, the correlation coefficients from the diet alone. And so that's summarizing that part. And so I've gone through this really quickly because I wanted to have a lot of time for discussion because this is really the first time I'm presenting this. So I'll just quickly go over, I think I have one conclusion slide and one future direction. So we think that the TNI, the creation of a TNI, it will offer new information about a different type of diet quality than the existing indices. Our preliminary validation research supports that it is a useful construct, at least in US adults. And again, we would want to extend this to other populations and other age groups. But this type of framework can be used in many different settings. There can be different nutrients, different population subgroups. It's really the framework that I think is something that we need to extend more research into. But there's a lot of applicability for this type of framework. And as we all are aware, increasing classification tools for exposure assessment are critical to our understanding of how diet relates to health, as well as looking at population adherence to dietary recommendations. So the dietary reference intakes, who is getting not enough, what population subgroups might be at risk for too much. And so I think I've talked about this, but we really want to adapt this to include different nutrients. This was kind of our first pass at the development of this. So we would want to examine the effectiveness of this tool for dietary interventions, understanding how to better kind of tailor this type of index with other kind of indexes. How do we relate those? So right now, what we've done is basic correlations, but how could they be combined together as a future direction? And at this first pass, we really focused on nutrient adequacy. And of course, we know that nutrient excess is another problem, particularly for people who use dietary supplements. So how can we incorporate that dimension in our future work? And then how can we relate TNI scores or this framework with health outcomes? So this represents most of the research from Dr. Alexandra Cowan, who just became a doctor, I think last week or 2 weeks ago from my lab, but we have a whole host of collaborators on this project, and they're listed here and their universities. And so we're really grateful that we had funding from the NIH, and from the NCI, as well as from the Office of Dietary Supplements. So thank you for listening, and I will be happy to answer any questions you might have.
Great, thank you, Dr. Bailey. And that was a really good walkthrough for this new index that you have validated very elegantly. And we will take our first question, which is basically, it's actually from Dr. Alice Lichtenstein. She asks, Regan, really interesting presentation. Can you comment on the synergy of data between the nutrients of concern and the nutrients of public health concern?
And we clarified that in the last iteration of the dietary guidelines. So a nutrient of public health concern, we call them food components because some of them aren't technically nutrients. So there's nutrients or food components of public health concern that are related to some clinical endpoint or a disease state or a validated surrogate biomarker. So sodium intakes are high, they're directly related to blood pressure. Calcium and vitamin D, given their role in bone health. We created a new category called public health relevance because many population subgroups are at risk for low intake, but there's not a clinical endpoint or a validated surrogate biomarker. So things like choline are very low relative to the recommendations, but they're not directly tied scientifically with as much research as, say, sodium and blood pressure.
Great, thank you. Dr. Roger Fielding asks, have you looked at scores in the over 80-year age range? This is the fastest growing segment of our older population.
No, we did see that as people age, they're more likely to use supplements, so they have higher TNI scores, but we haven't done any work really on the old population specifically. But I think, again, that's an important dimension that we should capture in future iterations of this.
Great, thank you. A comment from Dr. Jaspreet Ahuja. She says, great and very eloquent presentation as always. She says she has 2 questions. I don't see the questions, sorry. Dr. Jaspreet, if you could kindly post them again, because it says I have 2 questions and comments and the questions don't seem to be appearing. So please do post them and we will be sure to ask Dr. Bailey. The other comment is basically, good afternoon, thank you for the insightful presentation. I'm listening from Nigeria, and this is from Dr. Opeyemi Akintemenhin, and she asks, I'm listening from Nigeria. I would like to ask if this tool can be used in Nigerian population.
I think it can. It's really the whole concept of whatever nutrients are important to a particular population subgroup. So the ones that we looked at were shortfall nutrients in the 2015 dietary guidelines, but there may be different nutrients or food components of concern in Nigeria. And it's just relating usual intakes to that benchmark standard to kind of get a totality of nutrient exposures. So I think it can be applied in many different contexts with different nutrients, different populations.
Great, thank you. That I think sort of answers Dr. Larissa Mazepina's question, which asks if there are similar indices in other countries, and have you compared your data to other regions?
We haven't done any, I mean, this is we just literally graduated this student last week. I was going to give a different talk, but I thought it might be fun to show you some new data rather than stuff that we already had published. So we have a lot of hopes for trying this in different populations, different contexts, but this is really as far as we are right now.
Great, thank you. And the next question is from Dr. Johanna Dwyer. I know you know her way too well. She says, great talk and thanks. Could you comment on the formulations of the multivitamin mineral supplements and what % of DRI should be provided from DS4 micronutrients?
Oh, that's a very good question, Dr. Dwyer. What's interesting and something that I have always lamented with the supplement industry is many of the nutrients that we're really concerned about are generally not high amounts in the most commonly used products. For example, calcium, we know is ubiquitously low in the US population, but because it's such a big molecule, it's really hard to get a lot of calcium into a multivitamin. So most standard multivitamins have around 130 to 150 milligrams of calcium, which is about a half a serving of dairy. And so you're right, there's oftentimes a mismatch between what is in a product and what the public health need is. For example, we know from biomarker data that very few Americans have low serum and red blood cell folate, but there's a lot of folic acid in routinely used multivitamins. So you're very on point, Dr. Dwyer, with that question. There is sometimes a mismatch between what the product formulations are and what the public health needs are.
Thank you. The next question is from Dr. Cheryl Gilhooly. She's the lead for our dietary assessment unit and the metabolic research unit. She asks, first she has a comment. She says, thank you for the overview. This is great. Obviously, there can be challenges with defining food groups and supplement intake when looking at dietary patterns. Any challenges that you find using the TNI that differ from other dietary pattern scores? And would you be able to apply this tool on other dietary assessment methods, such as the FFQ, which have less specific information on supplement intake?
Those are both very good questions. So anytime you're dealing with dietary supplements, I always say nutrient intakes aren't bound by energy like they are with food. So people can have tremendous amounts of nutrients from dietary supplements, which makes modeling them very difficult because there's a long, long right-hand skew. And so what we did for the development of the TNI was we Winsorized those very high values down to the 98th percentile to make the estimates behave a little bit better. That's the primary challenge with, I think, supplement intake, is that there tends to be what we call spikes and skews. So the skew I already talked about, but there's spikes around the distribution where nutrients tend to flow in a supplement product. So for example, calcium, I said 135 to 150 milligrams. There will be a big spike and the distribution around that number because a lot of people are using these products. So those types of spikes and skews are really challenging when you're trying to get at usual or habitual intake. And we've developed some models around how to do that, but nevertheless, they really are challenging.
Okay, thank you. Here's another question from Dr. Alice Lichtenstein. She asks, for some of the nutrients, is the concern that the issue is not, the concern is that the issue is not that it's inadequate intake, but accurate EAR, for example, vitamin E?
That's a really good question. We are kind of beholden to the DRI framework, but there's a lot of uncertainty around certain nutrients and certain values. And vitamin D is a great example, or vitamin E is a great example, because we just don't see a lot of the endpoint that was set in the population. But when we look at dietary intakes, they often look woefully low. And so I think there's this process that Dr. Lichtenstein and I were involved with how can we update DRIs with enough scientific evidence? How can we do an evidence scan to see what nutrients need to be updated and what the available evidence is? But that's always a criticism, particularly in children, where values are oftentimes just extrapolated down from adult data. So we see many young children, for example, exceeding the UL for zinc and for folic acid. And is that really an issue, or is it really a DRI issue? So it's a great point.
Right, things that definitely need thinking. The next question and a comment is from Dr. Paul Jakes. He says, nice presentation, and asks, what are some of the additional nutrients that you're considering for future versions? Would fiber be one? How about folic acid as a potential overconsumed nutrient?
I think our next focus will really be on the overconsumption and how we can incorporate that into this framework. I think that the existing diet indices do a great job for fiber. And there's not traditionally in the US a lot of supplemental fiber use. So I think something like the HEI really captures the dimensionality of fiber. But I would love to hear comments on what other nutrients we should be including. We're kind of working our way through this, for sure.
Sure. Now we have Dr. Jaspreet Ahuja's question that's fully posted. The first question, she has two questions and one comment. The first question is, food composition databases such as the FDC are focusing on variability in composition. Are there any plans to incorporate variability in assessing intakes and subsequently the indices?
In this index, one of our goals is, it's not really the food composition database, but the supplement composition database, because we know that most of those rely on label declarations from the manufacturers. And Dr. Dwyer and others, Jaspreet has also been involved with the Dietary Supplement Ingredient Database project from ODS and USDA. So we know from all of that information that there's much more in the bottle that's in the label. And so the databases are all on label declarations. And so there are regression equations to take what's predicted from the database and what's actually being consumed. And so that's another thing that we kind of have on our to-do list, is how can we use that strong scientific work from the DSID team and improve our exposure classification for supplements.
Great, thank you. Her second question asks, sometimes I wonder if by focusing on few nutrients and combining nutrient intakes from foods and supplements, we undermine the value of a good diet. There are thousands of components in foods, and research has shown that nutrients obtained from foods and supplements vary in their impact on the body, as in retinol. Thoughts?
I totally agree with you. And I think that we do have very good measures like the Healthy Eating Index to get at diet quality from foods and beverages. But most Americans are using supplements. And so we're trying to make something that's complementary to the recommendations for a healthy dietary pattern, but also represents the context that we're living in, with half of adults and a third of children using these products. We're not trying to replace any of those foods and beverage-based indices or recommendations. We're not promoting the use of supplements. We're trying to get a more complete exposure classification.
Great, thank you. We have another question from Dr. Rita Aquino from Brazil. She says she's listening from Brazil and that they are using the DST, which is a dietary screening tool. Is it an index too? She asks. Not sure if that's what you wanted to ask.
The
Dr.
dietary
Aquino?
screening tool is something I created, oh my gosh, back in graduate school. So thank you for even knowing that it exists, because that was a long time ago. But the dietary screening tool really uses more of a foods and beverage based questionnaire. It's almost like an abbreviated food frequency questionnaire to get at, it's a screening tool to identify older adults who might be at nutrition risk based on their diet.
Great. That is pretty much all the questions we had from the Q&A and from the chat. And I know that you had said that you would like somewhat of a discussion and feedback. And do you feel like there has been, I know your future directions were great and answered some of the questions that we may have had, and good luck with the work, because it's very exciting to be looking at all those dimensions that you very nicely articulated. And yeah, definitely do call on us if you need any feedback, or if there are, developmental stages where you would like some feedback from our group. As you can see, it's a group that's very involved and very interested, and we're happy to help with any of those developmental processes. And do you have any questions that you would like to ask us before?
No, I think I got some really good comments, and if people have other ideas or they want to collaborate on this in different populations or with different nutrients, we are always amenable to that. And again, just thank you so much for being with me today and for sharing your questions and ideas. It's really helpful.
Great, thank you so much. And we look forward to hearing more about the TNI.
Okay.
Thank you.
Thank you.